Section 3.4, the slope of a line. Our first objective, find the slope of a line given 2 points. So to find slope of the line, it's m equals rise over 1, and that is y2 minus y1 over x2 minus x1. So for example 1, we want to use this formula to find our slope. So the first thing we want to do is always label your points. So we have x1, y1, x2, y2. So let me change that color. So now we're going to put it into our formula of m equals y2 minus y1 over x2 minus x1. It's really important to label your points so you don't get confused. Even if you're proficient, just label your points. Alright, so we have y2, which is negative 5, minus y1, which is negative 3, over x2, which is negative 2, minus x1, which is negative 1. Now our minuses in the middle become pluses. So we have negative 5 plus 3 is negative 2, and negative 2 plus 1 is negative 1, and negative 2 divided by negative 1 is positive 2. So our slope is positive 2. Moving on to B. So we have 2, 9, and 2, negative 3. Label your points. We have x1, y1, x2, y2. We're going to use the same formula. So we have y2, which is negative 3, minus y1, which is 9, over x2, which is 2, minus x1, which is 2. So we get negative 11 over 0. You can never have 0 in the denominator. That's impossible. So it's undefined. So if you get 0 in that denominator, it's always undefined. Now, moving on to C. x1, y1, x2, y2. Same formula. So we have y2, which is 4, minus y1, which is 4, over x2, which is negative 4, minus x1, which is 1. So we have 4 minus 4 is 0, and negative 4 minus 1 is negative 5. You can have 0 on the top. If you have 0 on the top, it's always going to be 0. Objective 2, we want to find the slope given an equation. So find the slope and y-intercept of each. To find the slope and y-intercept, it needs to be in slope-intercept form. It's called slope-intercept form because it gives you, when it's in that form, you can identify the slope and identify the y-intercept. So for A, it's in slope-intercept form. So A, the slope, is negative 1, and the y-intercept is 0, 5. Now, same thing for B. It's already in y equals mx plus b. So if to know that, y has to be by itself. So for B, our slope is 4, and our y-intercept is 0, 0. It's 0, 0 because there's nothing next to it. Now for C, we need to figure out what kind of line are we working with. It's y equals. Y equals that is a horizontal line. And if something is horizontal, it's flat. It doesn't have a slope. So our slope is 0, and our y-intercept, where do you think it crosses the y-axis? Well, it crosses it at 0, 1. Because if you were to graph this, that's where you would plot that point. Next, we have x equals 3. Now, if we take a look at that one, that's a vertical line. Vertical lines don't have a slope. So that's when you have an undefined slope. And it does not have a y-intercept. Since it only goes up and down, it doesn't cross the y-axis. But it does cross the x-axis at 3, 0. Objective 3. The adult one-day price, y, for Disney World is given by y equals 3.53x plus 67.39, where x is the number of years since 2006. Use this equation to predict the ticket prices of 2026. So from 2006 to 2026, that's 20 years. So if that's 20 years, y means the price, and x is the number of years since then. So that's why we have to figure out how many years has it been since 2006. So we want to plug that in for x. So we have y equals 3.53x, which is our 20 years, plus 67.39. So we have y equals, we want to do 3.53 times 20. That gives you 70.6 plus 67.39. Combine like terms. We get 137.99. And let's just round that to $138. So using this formula, using this model, because it models behavior, in 2026 we can expect the ticket prices to be $138. I highly doubt that. It'll probably be way more by then. Objective 4. Compare the slope of parallel and perpendicular lines. So parallel lines, two lines that never intersect, are called parallel lines. So parallel lines never cross. Parallel lines have the same slope and different y-intercepts, unless they are vertical lines which have no slope. Vertical lines are also parallel. So when are you ever going to need to use this? It's a joke. There's a song by Atlas called Parallel Lines, and to get the symbolism, you have to understand what parallel lines are, because parallel lines never intersect, therefore they never meet. So there you go. An application of when you're going to use it. Perpendicular lines, two lines that intersect at right angles, are called perpendicular lines. Two non-vertical perpendicular lines have slopes that are negative reciprocals of each other. So that means if you flip it and change the sign, it'll be the same thing. The product of their slopes will be -1. So if you multiply the two slopes, it equals -1. Horizontal and vertical lines are perpendicular to each other. So an example of what perpendicular lines look like. So if we have the slope A, a perpendicular line, if you flip it, it'd be 1 over A and change the sign to be negative. So for example 4, we want to determine if each set of equations are parallel, perpendicular, or neither. So in order to determine parallel, perpendicular, neither, we need to look at the slope. In order to look at the slope, it needs to be in y equals mx plus b form. That's slope-intercept form. So what we need to do is solve for y for each individual equation and each part. So we need to subtract 6x. So we have 2y equals -6x. Divide by 2. We have y equals -3. So our slope is -3. In our next problem, we have -3x minus y equals 3. We're going to add 3x to both sides. So we have negative y equals 3x plus 3. And then we need to get rid of that negative by dividing it. So we have y equals negative 3x minus 3. So here our m is negative 3. You see how they're identical? That means they're parallel. The reason why parallel lines never intersect because they have the same slope. So if they're rising at the same rate, if you're moving at the same rate, will you ever catch somebody? You can't. Moving on to b. So b, we have x plus 3y equals negative 15. We're going to subtract x to both sides. So we have 3y equals negative x minus 15. Divide everything by 3. So we have y equals negative 1 over 3x minus 5. So our slope is negative 1 over 3. Now we need to do to the other equation in this problem, which is negative 3x plus y equals negative 1. So we're going to add 3x. So we have y equals 3x minus 1. So if you notice this slope is 3. If we flipped negative 1 over 3, that gives us 3 over 1. And if we want to change it we have to change the sign so negative becomes positive. Therefore, these are perpendicular. If you wanted to be extra careful, just in case like they were similar fractions, but they don't look the same, you could multiply them. So if you multiply, we have negative 1 over 3 times 3 over 1. So we have negative 3 over 3, which is negative 1. So if you get that product of negative 1, they are indeed perpendicular. Alright, C. We have 5x plus y equals negative 6. We subtract 5x. So we have y equals negative 5x minus 6. That means our m is negative 5. Now we have to do the same thing to the other part of the equation. So we have x plus 5y equals 5. Subtract x to both sides. So we have 5y equals negative x plus 5. Divide by 5. So we have y equals negative 1 over 5 x plus 1. So our m here is negative 1 over 5. Now, these aren't perpendicular because they're not opposite signs. They're both negative, and they're not identical, so they're not parallel. They're neither.